Hello everyone. Welcome to the course Principles and Applications of Mechatronic Systems. Today we are going to study Chapter 5, Hydraulic and Pneumatic Control Technology, Hydraulic Transmission. The content of this lesson includes 1. Characteristics of hydraulic transmission and the composition of the system. 2. Working principle of hydraulic transmission, functions of commonly used hydraulic system components, and their graphic symbols. 3. Analysis methods for typical hydraulic systems. Transmission devices are used to transfer motion and power. They are generally divided into mechanical transmission, electrical transmission, and fluid transmission. Mechanical transmission, a method of transmitting power to the actuator through mechanical parts such as gears and belts. Electrical transmission, a method of transmitting or controlling power by means of electrical equipment and adjusting electrical parameters. Fluid transmission, a transmission method that uses a fluid as the working medium for energy conversion, transmission, and control. Fluid transmission includes hydraulic transmission and pneumatic transmission. Today, our focus is on fluid transmission. Fluids are divided into liquids and gases. Liquid refers to hydraulics, characterized by being nearly incompressible. The corresponding system is called a hydraulic system. Gas refers to compressed air, which is highly compressible. The corresponding system is called a pneumatic system. First, let's learn the application of hydraulic transmission technology. Hydraulic transmission technology is widely used in various fields, such as shield machines, presses, hydraulic jacks, cranes, excavators, and hydraulic fixtures in CNC machine tools. Basic knowledge of hydraulic transmission. Hydraulic transmission is a method of power transmission and control that uses a liquid, usually hydraulic oil, as the working medium and utilizes liquid pressure. It consists of various components forming basic functional circuits, which are then combined into a transmission system with specific control functions. For example, the mechanical energy from the motor driving a hydraulic pump is converted into pressure energy, which is then delivered through pipelines and control valves. The actuating components, hydraulic cylinders or hydraulic motors, convert this pressure energy into mechanical energy to drive the load and achieve the movement of actuators. Working principle of hydraulic transmission. Let's take the operation of a hydraulic jack as an example, as shown in the figure. 1. Small hydraulic cylinder. 2. Discharge check valve. 3. Suction check valve. 4. Oil tank. 5. Stop valve. 6. Large hydraulic cylinder. When the piston A1 of the small hydraulic cylinder moves upward, the hydraulic oil can only flow through suction check valve 3 into the small hydraulic cylinder 1, thus filling it with oil. When the piston A1 moves downward, the hydraulic oil can only flow through discharge check valve 2 into the large hydraulic cylinder 6, pushing piston A2 upward and generating an upward force to lift the load. After the work is completed, the stop valve 5 can be opened, allowing the oil in the large hydraulic cylinder 6 to flow back to the oil tank. Therefore, we can summarize the characteristics of hydraulic transmission. Hydraulic transmission is a form of transmission that uses the pressure energy of liquid hydraulic oil within a closed system to transfer motion and power. Its process is to first convert the mechanical energy of the prime mover into the pressure energy of the liquid for easy transmission, and then convert this pressure energy back into mechanical energy to perform external work. Composition of a hydraulic transmission system. Let's look at the hydraulic system of a machine tool work table. Its components include 1. Oil tank. 2. Filter. 3. Hydraulic pump. 4. Release valve. 5. Throttle valve. 6. Directional control valve. 7. Hydraulic cylinder. 8. Work table. The left diagram is the structural diagram of the machine tool work table hydraulic system. This type of diagram is almost like a sectional view of the actual system, with strong intuitiveness and easy readability, but the graphics are complex and inconvenient to draw. especially when there are many components in the system. It becomes harder to identify details and clearly express the relationships between the components. The right diagram is the hydraulic circuit diagram. This type of diagram uses simple symbols, is easy to draw, and clearly represents the working process of the hydraulic system. It is widely used in practice. Continuing with the machine tool work table hydraulic system as an example to explain the composition of the hydraulic transmission system. 1. Power elements device. Its function is to convert the mechanical energy input from the prime mover into the pressure energy of the fluid to drive actuators. Example: hydraulic pump in the system provides pressurized oil. 2. Actuating elements. Its function is to convert the pressure energy of the fluid into mechanical energy to drive the working parts. Example: hydraulic cylinder for linear motion or hydraulic motor for rotary motion. 3. Control and regulating elements. These components regulate and control the pressure, flow rate, and flow direction of the fluid in the system. Example: relief valve, throttle valve, directional control valve. 4. Auxiliary elements. Other elements in the system aside from the 3 parts mentioned above. Example: oil tank, filters, pipelines, etc. 5. Transmission medium. Its role is to transmit motion and power. Example: hydraulic oil. Next, let's learn hydraulic system symbols. Graphical symbols only indicate the function of components, not their structure or parameters. They're simple, clear, and easy to draw. Examples: oil tank, hydraulic cylinder, hydraulic pump, filter, relief valve, throttle valve, directional control valve. As shown in the diagram, X position and X-way, the box represents the position, such as 2 position or 3 position. The ports represent the passageways, such as 2-way, 3-way, 4-way, or 5-way. Typical hydraulic transmission systems. Next, let's learn typical hydraulic system. 1. Directional control circuit. When solenoid 1Y is energized, oil supply path, hydraulic pump 1 to directional valve 2 in left position P port to A port to left chamber of hydraulic cylinder. Return oil path, right chamber of hydraulic cylinder to directional valve 2 in left position B port to T port to oil tank. When solenoid 1YA is de-energized, oil supply path, hydraulic pump 1 to directional valve 2 in right position P port to D port to right chamber of hydraulic cylinder. Return oil path, left chamber of hydraulic cylinder to directional valve 2 in right position up port to T port to oil tank. 2. Pressure control circuit. This pressure regulation circuit is used in a throttle speed control system with a constant displacement pump. As shown in the diagram, because the pump's flow rate is greater than the flow through the throttle valve into the hydraulic cylinder, the oil pressure rises to the set value of the relief valve, opening the relief valve so excess oil flows back to the oil tank. During the relief process, the system pressure remains basically stable as the oil pressure balances with the spring force of the relief valve. 3. Speed control circuit. When 1Y is energized, 2YA is de-energized, and 3YA is energized, the piston moves quickly to the right. The oil from the right chamber of the hydraulic cylinder flows directly back to the oil tank through the left position of directional valve 1 and the right position of directional valve 2. When 3Y is de-energized, the return oil flows back to the oil tank through the throttle valve 3, changing the piston movement from fast to slow. In this lesson, we focused on learning the following contents. 1. The working principle of hydraulic transmission. 2. The composition of a hydraulic transmission system. 3. Hydraulic system graphic symbols. 4. Typical control circuits of hydraulic transmission systems. Thank you for your attention. See you in the next class.